Okay, here's a third bond pricing problem. This one's a little trickier, but it will allow us maybe some good intuition by solving the problem here. So let's read the question and then let's talk conceptually about what's going on. Suppose you bought a 10-year bond at par 1 year ago. The face value of this bond was $1,000. The coupon rate's 8%, and interest rates have remained relatively constant during the past year. However, today, interest rates spiked and increased 1%. What is the price of the bond today? Okay, so we have a couple of different moving parts. Last year, we bought this bond at par. Remember that par value is the same thing as face value, which means that we bought this bond last year. It had 10 years until maturity. We bought this bond at $1,000. Okay, so I'm just going to make a note of this here and say last year we bought the bond at $1,000, which means the yield to maturity is equal to the coupon rate, or the yield to maturity last year was 8%. Okay. So it says today interest rates spiked and increased 1%, which means that the yield to maturity, the actual interest rates that we're dealing with, the yield to maturity is no longer 8%, now it's 9%. Okay? So that's the change, is today we're going to go ahead and solve for the present value of the bond. And there's a couple of things that we have to think about before we do this. Okay, for instance, the future value or face value of the bond remains the same. It's still $1,000. The payment, the coupon payment on the bond, again, we don't assume that coupons were paid anything other than annually. So our coupon payment is still $80 per year. And here we had an 8% I over Y last year. We're going to add 1% to that given the information in the problem, which gives us a yield to maturity of now 9%. Last year we had 10 years to maturity. 1 year has gone off, so we're left with 9 years to maturity. Hopefully this makes sense. And we're going to solve for present value. Before we do, let's talk conceptually about what's going on here. If you look here at the formula, the price of a bond is equal to the present value of the coupons of the bond plus the present value of the face value of the bond, where we're discounting these coupons and face values by the yield to maturity R. All right? As R increases, as the yield to maturity increases, holding everything else constant, the price of the bond must decrease. Hopefully you can see that mathematically. Intuitively, it also makes sense. As the market requires a higher interest rate, actual interest rate, a higher yield to maturity, then the market will only be willing to purchase the bond at a deeper discount. Okay? So what's happening is there's an inverse relationship between the yield to maturity and the price of the bond. So in the framework of our question here, when interest rates spike and increase 1%, that means the price of the bond decreases. We bought the bond at $1,000 last year. We assume now, because the yield to maturity is 9% instead of 8%, that the price of the bond will be lower than $1,000. Hopefully this makes sense. Let's calculate the price of the bond given the new information. We have $1,000 negative face value. Again, that's $1,000 principal payment. That's an outflow from the firm's perspective. We have a coupon payment of 8% of the face value, or $80. Again, that's negative from the firm's perspective. That's an outflow. I over Y is now 9% given the 1% increase from last year. N is also equal to 9. The bond will now mature in 9 years because a year has come off the calendar on this 10-year bond that we purchased 1 year ago. I'm going to compute present value, and when I do, we better see that the price of the bond is now something lower than $1,000. Compute present value, and we get a price of the bond equal to $940 and about 5 cents.